Okay, what is the equation of this line? Does anybody have an answer? Okay. Very good. The y-intercept is right here at -2, so that's why she has that in the b place of the equation. And then to get from one point to the next, you have to rise 3, run 1. 3 over 1 is the same thing as 3, so that's why that's her m, her slope. Okay, now turn to page 12 in your packet. Okay, today we're going to graph lines, and not only are we going to identify the y-intercept, we're going to learn how to identify the x-intercept. Okay, so let's start with this first equation beside A. To be able to graph this, what do we do first? Right. Maybe at the end. Put it in slope-intercept form, y equals mx plus b. So to do that, what do we need to do first? Minus 5x. On the left side, they cancel because 5x minus 5x is 0, so it's gone, leaving 3y equals 15 minus 5x, or we could go ahead and put the negative 5x first and the positive 15 second, since we want to mx and then b anyway. Now what do I need to do? Divide by 3. And so y equals negative 5 over 3, because that won't reduce, x plus 5. Okay, so to graph this line, you need to identify the slope and the y-intercept. What is the slope? Negative 5 over 3. And what is the y-intercept? 5. So on the y-axis, you go up to 5 and plot your y-intercept. And then from there, to get to the next point, you go down 5, right 3. And see how that point lands on the x-axis? So that's your x-intercept. You may. Raise your hand if you want her to give you one while she's up. Go down to C. Okay, now while I go over C, it's a little more difficult. So I'd rather you just watch, and then I'll give you time to copy. Okay? So Marcus, do you hear me? You're going to have time just to watch, and then you copy later, because this one's a little different and it's not easy. The first thing I'm going to do is I'm going to get it in y equals mx plus b form. Well, this is my mx, and it's positive 1/2 x, so to cancel it out on this side, I subtract it, and then I have to do the same thing on the other side. So now I have a negative 8y on the left side of the equation, and a 4 minus 1/2 x on the right, or I'll go ahead and rewrite that as negative 1/2 x plus 4. So right now that's looking okay, but then to get y by itself, you have to divide by negative 8, which gets a little messy. Those cancel because anything divided by itself is 1, and there's no reason to write the 1 beside the y. It's understood to be there. Now, a negative divided by negative is a positive. So when I type this in the calculator, I'm not going to worry about the signs because I already know they're going to cancel each other out. In the calculator, I'm going to type in 1/2 divided by 8. To type in the 1/2, I do alpha y equals n over d. Type in the 1/2, and then come out from the fraction before hitting divided by 8, and you'll see that that simplifies to a 1/16. So we have 1 over 16x, and then your y-intercept is going to reduce to a negative 1/2. Okay, so go ahead and take the time real quick to write that. All right, now just watch again, okay? So that means that the slope is 1 over 16. So rise 1, run 16. The y-intercept is negative 1/2. So that's the one I plot first. Well, think about it. Negative 1/2, let me zoom in so we can see the graph bigger. Negative 1/2 would be right here in the middle, correct? Between 0 and negative 1. Well then, if you're supposed to go up 1, don't you have to go all the way to right here? In between those? And then if you go over 16, that's 10. So it'd be like 11, 12, 13, 14, 15, 16, about right here. Okay, now, just think for a second. isn't going up 1, right 16 going to be the same thing as going up a half, right 8? Think about it. Instead of going up 1 and right 16, since that goes off the graph, wouldn't it still be on the same line if you just went up half and then right 8? So if you go up a half and then right 8, you will land right here, which, look, still is in the same line as those other two that I had already plotted. Okay, so now go ahead and graph it. And that's what your line should look like. Why is this line almost flat? Well, right, because 1/16, let me show you this real quick. 1/16 is very close to 0, isn't it? And remember, if it were all the way down to 0, it would be what kind of line? Completely flat, right? But this one is barely above 0, so that's why it's got a teeny bit of steepness, but not much. Okay, is everybody done with that one? Okay, now let's go back up to the A again, and I'm going to show you another method to solve these so that when you run into a problem like this, you have another option besides what we just did. Okay, sometimes equations are given to you in standard form. Okay, standard form is AX plus BY equals C. So that's standard form. AX plus BY equals C. Now, just like in y equals mx plus b, it doesn't always have to be a plus. It can be a minus. Same thing right here. This could be a minus and still be standard form. But the 5x is your AX, the 3y is your BY, and the 15 is your C, your constant. So instead of taking the time to rearrange it into slope-intercept form, there's another option. You can take your 5x and set it equal to the 15. You can take your 3y and set it equal to the 15. And then you just solve each one individually. To solve this one for x, what would we do? Divide by 5, and you get x equals 3. Well, if you go to the x-axis and you go over to 3, isn't that the same point we got a while ago when we graphed it the other way, the same x-intercept? And then let's do the other one. If we solve this one for y, we would divide by 3 and get y equals 5. Well, if we go to the y-axis and go up 5, doesn't that land in the same place it did a while ago when we did it in slope-intercept form? But don't you almost think it's easier to do it this way instead of taking the time to rearrange? Okay, now, some of you are very good at rearranging and graphing, and so you might just choose to still rearrange. But it is helpful on problems like C to do it the way I just taught you. So can I move down to C? Up 5. Because we ended up with y equals 5. Yeah, because today we're just focusing on the x-intercept, which is where the line hits the x-axis, and the y-intercept, which is where it hits the y. Okay, so now let's look at C and do it with this method. Okay, because see how when we rearranged this one, it got pretty messy while rearranging it, and then we couldn't even fit it on the graph by going with the original slope. So now let's do it with the new method. 1/2 x is your AX, 8y is the BY, and then 4 is the C. So this one's in standard form. So I'm going to take the 1/2 x and equal it to 4, and I'm going to take the negative 8y and equal it to 4. To solve this one for x, what do? You can by what? Correct. Instead of dividing by 1/2, you can do keep, change, flip, and multiply by 2 over 1, which is just 2. And then you would do that to the other side. And you would get x equals 8, because 4 times 2 over 1 is 8. And then over here to solve for y, what would you do? Divide by negative 8, and you would end up with y equals negative 1/2. Remember, if the top number is smaller, you're going to have a fraction. Okay, well, aren't 8, wasn't that our original x-intercept when we graphed it this way? And negative 1/2 was our original y-intercept when we did it this way? But I think with this particular problem, since the slope ended up a number that went off the graph, it's easier to do with our new method. Okay, so now I want you to take a couple of minutes and try B and D by yourself. Okay, so for this one, it's in standard form, ax plus by equals c. So instead of me taking the time to rewrite this one in slope-intercept form, I'm going to use my new method. I'm going to take that negative 2x and set it equal to 10. And I'm going to take the 5y and set it equal to 10. And then I'm going to solve for x and for y. To solve for x, you just divide by negative 2. And you end up with x equals negative 5. So that's your x-intercept. On the x-axis, you go to negative 5 and you plot your point. Okay, for the y, you would have to divide by 5 and you end up with y equals 2. So on the y-axis, I'm going to go up to 2 and plot a point, and then that's sufficient to make a line. All you really have to draw a line is 2 points. Let's get this line. Okay, so that's all you have to do. Yes? What? It works for the ones that are in standard form. Ax plus by equals c. You should just do those in y equals mx plus b form. Okay, let me show y'all what? Because in standard form, it's ax, by, and then c. So your x, then your y, and then equals c. If it's already in that form, you can do it this way. Okay, let me show you. You don't have to write this, but say you decided that you would rather do it in slope-intercept form. The first thing you would have done is taken that negative 2x and added it to the other side. That would have given you 5y equals 2x plus 10, and then you would have just divided by 5, and you would have gotten y equals 2/5 x plus 2. To graph that, you go to 2 and plot your y-intercept, and then from there you go up to right 5, or down to left 5, which would have landed you in the same place. Okay, now let's look at D. Is this one in standard form? Yes. You have your ax, then your by, then equals c. So we can use our new method where we just set each part equal to the c value. To solve for x, you divide by 4 and you get x equals 6. So that is your x-intercept. To solve for y, you divide by 3 and you get y equals 8. So x equals 6, 1, 2, 3, 4, 5, 6. Y equals 8 would be up here at the y-axis of 8, and then there's your line. Yes? Okay, well, let's see. Here's my point. So down 1, 2, 3, 4, 5, 6. Oh, but never mind, 8, because it's 8. 7, 8, 1, 2, 3, 4, 5, 6. So yes, that is the slope. Remember though, slope is rise over run. And remember in the formula, don't the y's go up top? So the 8 would go on top, and then the runs go in the bottom. So 6 would go in the bottom, but it's negative, so you'd have to put a negative on there. Okay, now let's move on to page 13. We have quite a bit of problems to do today, but there's not going to be any homework. Okay, number 1. A car owner recorded the number of gallons of gas remaining in the car's gas tank after driving a number of miles. Use the graph below to answer the following questions. Anytime you're given a problem with a picture or a graph, the first thing you should do is look at it and make sure you understand it. The x-axis is from 0 to 500, and those numbers represent what? Right, miles. Okay? And then on the y-axis, it goes from 0 to 20, and those numbers are in gallons of gas. Okay? So, A wants to know, what does the x-intercept represent on the graph? Well, what is the x-intercept? But, like, what is the actual x-intercept numerically? 500, 0, right? Like, if you had to go to that point sitting on the x-axis, it's right 500 and then up 0. What does that mean in terms of this word problem? So after 500 miles have been driven, there's 0 gas remaining. Okay, so after 500 miles are driven, 0 gallons remain in the tank. Okay, so B wants to know, what is the y-intercept and what does it represent? Correct. The y-intercept is 0, 20, because to get to the y-intercept, you just go up 20 on the y-axis, nowhere on the x. Right. Before you've started your trip, your tank started with 20 gallons of gas, right? So you could, there's many ways to write this. You don't have to write it exactly how I do. I'll just say you started the trip with 20 gallons of gas in the tank. Okay, and then C, what does the point 200, 12 represent on the graph, and is the point of solution on the graph? Well, if you go right 200, up 12, do you land on the line? Yes, it would be about there. So it is a solution because it's on the line. But what does it mean? Correct. After 200 miles are driven, 12 gallons remain. So that's one way to write it. Another way you could have said it is, after going 200 miles, you've used 8 gallons of gas. Can you also say that? There's no right or wrong way to say that, as long as you have, the right numbers, of course. Probably. But I mean, it could be a multiple choice where you just have to read through them and pick the right one. I'll have to look at the test. Okay, D, what does the point 410 represent, and is the point of solution? Is 410 on that line? No, if you go right 400 up 10, you're not on the line. So it's not a solution, and it has no meaning. Okay, it means nothing in this problem. Okay, I'm going to give you about a 1 minute head start to look at number 2, A through D. See if you can figure out some of those by yourself on number 2. The graph below shows the relationship between the number of mid-sized cars in a car dealer's inventory and the number of days after the start of a sale. What does the x-intercept represent on the graph? Well, what is the x-intercept? 15, 0. Okay, because that's where it hits the x-axis. And what does that mean? Right, so after the sale went on for 15 days, no cars were left. I mean, you could write that several different ways. Okay, what about the y-intercept? What is the y-intercept here? 0, 150, and what does that mean? Right, so before they started the sale, there were 150 cars in inventory. So there were 150 of those mid-sized cars in inventory at the start of the sale. Okay, what does the point 1050 represent, and is that point a solution? It is a solution because it's on the line. They even plotted it for you. And what does it mean? Correct. After 10 days of the sale going on, no, 50 cars were left. So 100 had been sold. So after 10 days, 50 cars remained. Okay, and then D, what does the point 5, 125 represent, and is it a solution? No, it's not on the graph, and it means nothing because it's not on the line. Okay, now turn to page 15. All right, number 7, the graph shows the altitude of the plane, the height of the plane. They want you to first find the plane's rate of change during the first hour. Well, if you look over at the graph, the x-axis is time, but it's not in hours, it's in minutes. So for the first hour, we're looking from 0 to 60, correct? Well, how do you find rate of change? What is rate of change the same as? Slope. Okay, rate of change equals slope. And to find slope, don't you just either calculate the y2 minus y1 over x2 minus x1 or count rise over run? Okay, so if we're looking in the first hour, that's from 0 to 60 minutes. So you would start here and go to here where it was 60 minutes. That's a rise of how many feet? 30,000, and a run of how many minutes? So that's 30,000 feet over 60 minutes, which reduces to no, 30,000 over 60. What's right? 500 feet, and that's 500 over 1, right? So 500 feet per minute is how fast that plane is rising, going up 500 feet every minute. Okay, now they want you to find the plane's rate of change during the second hour. So we need to, for the second hour, don't we focus in on what the graph's doing between 60 and 120? So from here to here? Right. Because you know how when you get on a plane, first you take off and it goes up for a while, but then once it reaches so many feet in the air, it levels out and stays there until it's time to descend. So this one would be 0 feet per minute because it has reached its maximum altitude and it's staying there until it's time to go back down. All right, number 8. An industrial safety study finds that there's a relationship between the number of industrial accidents and the number of hours of safety training for employees. This relationship is shown in the graph below. First, they want you to find the rate of change, and whenever they ask you to find the rate of change, they're just asking you to do what? Slope. And to do slope, don't you have to have 2 points or either rise over run? Well, we have 2 points, 0 to 70, and 27, 0. So when you plug them in the slope formula, it'll be what minus what? Zero minus 270, because look, this is your x1, y1, x2, y2. It's always this one minus this one over this one minus this one. So 27 minus 0. That then simplifies to negative 270 in the top, positive 27 in the bottom, which reduces down to negative 10 over 1. Can anybody tell me what that negative 10 over 1 represents in this scenario? Okay, 10 is accidents, and that 1 is hours. So what does that mean? Yes, you can. For every hour of training, for every 1 hour of training, there are 10 less accidents. They're saying, like, to reduce the accidents that are occurring, they've made their employees do the safety training, And they've discovered that for every hour of training, there are 10 less accidents than there were before the training was started. And we even have to do those. Like, we have to do safety training. Like lifting objects. Yeah. Yeah, if you don't watch the video and pass the test. Yeah. Okay, now go to page 16. We're almost done. All right, go all the way down to the bottom. Example 2. Using the previous graph, calculate the average rate of change of the savings account for the following. Okay, when we look at that graph, they want to know the rate of change from month 1 to month 4. Well, month 1 would be 1 comma what? 1 comma 400. After 1 month, there was $400. Month 4 would be 4 comma 700. So to find the rate of change, don't we just quickly calculate the slope? So that would be 700 minus 400 over 4 minus 1, and that becomes 300 over 3, which then becomes 100 over 1. And what does that mean? $100 every month. Okay, now for B, month 7 to month 8. Month 7 would be how much money? I think it's 1,000. And then month 8 had how much money? 1,100. 1,100. So we'll do 1,100 minus 1,000 over 8 minus 7, and you get right, $100 for every month. Why do you think they're the same, and they were the same as the example they did for you? Right, because it's a linear function. Okay, it's not going to change. It wouldn't matter what months you pick. Like, you could go from month 4 all the way to month 12, and after reducing, you'd still end up with 100 over 1. Okay, fill in this blank at the top of the next page. In a linear function, the average rate of change is always constant. Okay, tomorrow we got to do a little catching up in this class because somehow we got through example 3 and all the other classes.